Now, we are in our part 2 of our discussions about electrostatics, fundamentals of electric charges at rest. We'll now take a look at the units that are used in the study of electrostatics. First one is the unit of Coulomb. Coulomb, or the unit symbol C, where in formula it is letter Q sub C, is the International System of Units, or unit of electric charge. Under the 2019 redefinition of the SI base units, which took effect on 20th May of 2019, the magnitude of 1 coulomb is equal to the charge carried by approximately 6.242 times 10 raised to 18 electrons. Therefore, 1 coulomb is equal to 6.242 times 10 raised to 18 number of electrons. In everyday language, 1 coulomb, or a unit of coulomb, can refer to many things. The charges in static electricity from rubbing materials together are typically a few microcoulombs. The amount of charge that travels through a lightning bolt is typically around 15 coulombs, although for large bolts, this can be up to 350 coulombs. The amount of charge that travels through a typical alkaline AA or AA battery from being fully charged to discharge is about 5 kilocoulomb, roughly equivalent to 1400 milliamperes hour. A typical smartphone battery can hold 10,800 coulombs, or approximately equivalent to 3,000 milliamperes hours. 1 coulomb is a huge charge. If you scuff your feet in the carpet, transferring 1 coulomb of charge to your body from the carpet, something would happen to you. You will be electrified and fried. Static electricity on your body is usually only a few microcoulombs, by the way. The amount of charge that an object has is difficult to measure directly. Scientist Charles Augustin de Coulomb and his experiments in 1785, however, showed that the quantity of charge could be related to force. So the size of a coulomb is derived from the ampere. We'll talk about the ampere after this. 1 coulomb is now defined as the amount of charge flowing when the current is 1 ampere. But what if we want to know how fast charge moves? And that's why we have the other unit, ampere. The ampere, or unit symbol A, and formula that is letter I, big I, often shortened to amp, as you can see in your appliances, is the base unit of electric current in the International System of Units, or SI. It is named after the scientist André-Marie Ampere, who lived between 1775 to 1836. He is a French mathematician and physicist considered the father of electromagnetism. An ampere is a measure of the amount of electric charge passing a point in an electric circuit per unit time with 6.242 times 10 raised to 18 electrons, as we have defined in the previous slide, or 1 coulomb per second, consisting 1 ampere. 1 ampere mathematically is equivalent to 1 coulomb per second, or in symbols, I is equal to Q sub C divided by T, where I stands for ampere, and Q sub C stands for electric charge per coulomb, and T stands for the time in seconds. The definition of the SI unit of current, the ampere, comes from the study of magnetism. That is derived in this phenomenon where electric currents in wires give rise to magnetic fields. Those magnetic fields in turn give rise to magnetic forces in the wires. It is said that two parallel wires carrying a current exert a force on each other. But where does the electric charge ultimately come from? In 1897, J.J. Thomson proved the existence of the electron. 12 years later, starting in 1909, Robert Millikan performed his oil drop experiments to establish the charge of the electron. Now called elementary charge, or Q sub E, is the magnitude of the charge carried by a proton or an electron. So the charge of an electron, or electron charge, or we call it elementary charge or unit charge, can be expressed in coulombs as the charge of the electron, or E, is equal to 1.6021766634 times 10 raised to negative 19 coulomb. Or simply we write it as negative E. The charge of a proton is the exactly same of magnitude as an electron, but positive charge, or we write it as positive E. To find out the unit charges, or the number of electrons present in a quantity charge in coulomb, we use the formula Q sub E is equal to Q sub C times 6.242 times 10 raised to 18, where Q sub E is the unit charges, or the number of electrons present in a quantity charge in coulomb, where Q sub C is the charge in coulomb of an object.